Hello everybody, this is Praveen Kumar, lecturer, Government Polytechnic Kartiki, welcoming you to the 6th session of the Unit 6 of Mechanical Measurements, that is Limits, Fits and Tolerance. So we will be starting with the session 6. So before we go to the actual topics of the session 6, we will have a recap of what we have learned in the previous session. In the previous session, we have learned about what is tolerance and the systems of tolerance, and that is unilateral tolerance and bilateral tolerance. We have also learned some of the differences between the unilateral tolerance and bilateral tolerance. I would just have a recap on what we learned in the previous session. Variation in size or dimension is called as tolerance. Thus, the word tolerance indicates that a worker is not expected to produce the part of the exact size, but definite a small size error is permitted. The difference between the upper limit and the lower limit of a dimension represents the margin for variation to workmanship, and it is called as tolerance zone. Tolerance can also be defined as the amount by which the job is allowed to go away from the accuracy and perfectness without causing any functional trouble when assembled with the mating part and put into the actual service. So there are two types of tolerances, that is unilateral tolerance and bilateral tolerance. Unilateral tolerance is the dimension of a part is allowed to vary only one side of the basic size, that is, the tolerance lies only on one side of the basic size, either above or below it. Whereas in bilateral tolerance, the dimension of the part is allowed to vary on both sides of the basic size, that is, the limits of tolerance lie on either side of the basic size, but may not be necessarily equally disposed about it. In this system, it is not possible to retain the same fit when tolerance is varied and the basic size of one or both of the mating parts are to be varied. This system is used in mass production when machine settings is done on the basic size. And whereas in unilateral system is preferred in interchangeable manufacture, especially when the precision fits are required, because it is easy and simple to determine deviations. Another advantage of this system is that go gauge ends can be standardized, as the holes of different tolerances grades have the same lower limit and all the shafts have the same upper limit, and this forms of tolerance greatly assists the operator when machining on mating parts. The operator machines to the upper limit of the shaft, knowing fully well that he still has some margin left for machining matching before the parts are rejected. So this is what we learned in the previous session. We also learned some of the differences between the unilateral tolerance and the bilateral tolerance. So now we'll know what we are going to learn in this session. In this session, we'll be learning about machine tools alignment testing, geometric check on machine tools, some of the equipments for geometric or alignment tests. So before we know what is machine tools alignment testing, we'll just know what is the importance of machine tool geometrical test on machine tool. That is, the dimension of a gauge, surface finish and geometry are dependent upon the inherent quality and accuracy of the machine tool for its manufacturer. Also in mass production, the various components produced must be of such accuracy that they may be assembled on a non-selective basis. The accurate production of the component parts depend upon the accuracy of machine tools. The continuously increasing demand for highly accurate machined components has led to considerable research towards means by which the geometric accuracy of machines may be improved and maintained. It is very important, therefore, that under static conditions the alignment accuracy of the machine tools is checked by some of the geometric tests. The test which check the alignment accuracy of the various parts of a machine tool are called as static tests. Before we go further, we will have a detailed what do we need? The geometrical test. As we know that the accuracy of manufactured parts depends upon the accuracy of machine tools. The quality of workpiece depends on rigidity and stiffness of machine tool and its components. Alignment of various components in relation to one another, quality and accuracy of driving mechanism and control devices. It can be classified into static tests and dynamic tests. Static test. If the alignment of the components of the machine tool are checked under the static conditions, then such tests are called as static test. What about dynamic test? So dynamic test, if the alignment tests are carried out under the dynamic loading condition, the accuracy of machine tools which cut metal by removing chips is tested by two types of tests, namely geometrical test and practical test. So geometrical test, the dimension of components, position of components and displacement of component relative to one another is checked. In practical test, the test pieces are machined in the machines. The test pieces must be appropriate to the fundamental purpose for which the machine has been designed. So now we will know what is the purpose of machine tool testing. The dimension of any workpiece, its surface finish and geometry depends on the accuracy of machine tool for its manufacture. In mass production, the various components produced should be of high accuracy to be assembled on a non-sensitive basis. The increasing demand for accurately machined components has led to improvement in geometric accuracy of the machine tools. For this purpose, various checks on different components of machine tools are carried out. Now we know what is the next geometric test. So geometric check on machine tools. The various geometrical checks generally made on machine tools, that is, before conducting these tests, it is essential that the machine is set up and principal, horizontal and practical planes and axes are checked with spirit level, etc. There are different types, that is, geometrical test is checked on the straightness, flatness, squareness of the straight lines and planes, rotations, parallelism, equidistance and coincidence, movement of all working components. Under the straightness test, it is tested for line in two planes, sideways of machine tools, straight line motion. And under the rotations, it is tested for out of round, eccentricity, radial throw of an axis at a given point, run out, periodical axis slip and turning. And under parallelism, equidistance and coincidence testing, it is tested for parallelism of lines, parallelism of planes and parallel motion. So these are all different geometrical tests which are conducted on a machine tool. So before we know further, we will see some of the videos which will describe you about the how the flatness is tested and the parallelism is tested. So please do watch the video. Firstly, we will see how exactly the flatness is tested. Please watch the video. That was one of the video which we watched, which is used to check the flatness of a machine bed by one of the technology which is available in the market. Right? Though there are many other ways, that was one of the ways. Right? And now we will watch one more video which will give you, which shows you how exactly the straightness is checked by one of the methods. Please do watch the video.
For straightness measurement of a machine slideway, I would use the Taylor-Hobson Ultra Autocollimator with its wide range and high accuracy. With the system as standard, you get a laser alignment aid and a tablet PC which acts as the autocollimator's digital display, as well as having the Taylor-Hobson application software packages preloaded. An autocollimator measures angle very accurately, and we use a reflector as the target. Mirrors need to be flat and of very good surface finish. There are various mirrors, but normally we use this one, the 14224, which is a 50mm diameter mirror. Now before we start measuring, we need to check the fixturing, the environment, the orientation and tracking, and the alignment. So first, to check the fixturing. Normally I just touch the back of the autocollimator or the fixturing it's sitting on and seeing if that affects the reading of the autocollimator. Environment, what we're looking for here is temperature gradients or air turbulence. What we don't want is things like fans, open doors, affecting the light path of the autocollimator. Now we need to set the orientation and tracking. What we want to see is when the mirror tilts backwards and forwards, in other words going up and down, that the autocollimator is set so it also measures just up and down. How I normally do this is if I move the mirror, if I twist the mirror left to right, we should only have one axis on the autocollimator moving. The second axis should remain stationary. Alignment. What we need to make sure is that the autocollimator is pointing at the center of the mirror. This is easily done by using the laser sighting aid, which is provided as standard with the instrument. And what we then do is we move the mirror from the front to the back of the rail and then back to the front again, and make sure we have a signal all the way along the length of the rail. As we said earlier, the autocollimator gives you the angle of the mirror. What we have to do is sit this mirror onto a base, either an adjustable base as shown here or an ordinary fixed base. So if the autocollimator gives us the angle and we know the length of the base, then the software can calculate the height changes. The autocollimator can measure in two axes. It can measure the top surface of the slideway but also the side surface. If you're measuring the side surface, you will need some kind of side feed or side fence. We also offer simple, intuitive software for these products that will give you information on straightness measurement, flatness measurement and polygon measurement. This software is provided as standard with the Ultra Autocollimator, already loaded on the tablet PC. With the addition of an optical square, you can measure squareness and also parallelism. With the addition of the Tallyvale electronic level, we can also measure twist or roll. Hopefully this short guide has been of some help to you. If you need any more information or further training, please contact us at Spectrum Metrology. Thank you.
So that is what is checking the straightness of a bed by using autocollimator. So I hope we have understood how exactly the straightness of the bed is checked and flatness is checked. Likewise, we have many other tools which have been using or which have been used to check another other the geometrical tests that are explained in this session. So we will now know some of the tools which are being used for checking the geometrical test. So they are some of the equipment they are dial gauges, test mandrel, straight edges and squares, spirit levels, autocollimeter, alignment telescope, water levels and wavelength meter. So these are all some of the equipments which are used for geometrical or alignment tests. So that is it for this session. So we will be having the further topics in the next session. Thank you.